Hello and welcome. Operations Research, the chapter Replacement Decision, replacement of items, the efficiency of which deteriorates with time, high cost items like machine or plant, anything, and the model is replacement policy for the items, running cost of which increases with time, and we are ignoring the time value of money at this stage. So the asset is high value, its efficiency deteriorates with time and its running cost increases with time. That is the main thing. Now this case with us is, there is a machine, the cost of which is rupees 1,20,000 including installation etc. When the company starts to use the machine, total cost incurred is 1,20,000 rupees. The other information as a part of question given is, before this red line, this is part of question as well as solution. There are data for 5-year resale value which decreases with time. This is the say point, something different from the first case we have already discussed in the previous lecture. In that case the resale value or scrap value was constant. Now this is more practical. Resale value decreases with time because with passing the time the efficiency of the machine deteriorates. So resale value decreases. Now the running cost is not given as a single amount. There are two main components of running cost. One is maintenance cost and another is cost of labor and spares etc. This is nothing, just add these two, the result will be running cost. So maintenance cost plus cost of labor and spares makes the running cost. Now we have already discussed the process of solution. First we have to find out the cumulative running cost. You can write this year by year also. To use minimum possible time to discuss all the points, I have already written all these things. Now this is cumulative. In first year it remains same. First year plus second year, total cost of 2 years, total cost of 2 years plus third year, total cost of 3 years, total cost of 4 years and total cost of 5 years. This is nothing like cumulative frequency. Now depreciation cost. In this particular case, depreciation cost is not constant like in the previous case. Why? Because the resale value decreases or changes every year, the depreciation cost has to be changed every year. The cost remains constant. Subtraction of scrap value or resale value is the depreciation cost. 1,20,000 minus resale value at the end of first year 84,000. So for the first year depreciation cost comes to rupees 36,000. 1,20,000 minus resale value at the end of 2 years 60,000. Remaining 60,000 is depreciation cost for the second year. 1,20,000 minus 40,800 the resale value at the end of third year. The result is 79,200, that is depreciation cost for third year. 1,20,000 original cost minus 28,800. So 91,200 is the depreciation cost for the fourth year, and similarly 1,20,000 cost minus resale value or scrap value at the end of fifth year 19,300. The depreciation cost comes to 1,700,000 for the 5 years. Now if we add these two, the result will be total cost. And now if we add these two, the result will be total cost, and we are going to divide the total cost by the respective number of years. The result will be average cost. Now for the first year 36,000 plus 36,000, the total cost comes to 72,000. It is for 1 year only, so we have to divide it by 1. The result is 72,000. The interpretation is, if we use this machine for 1 year, the total cost we have to incur is rupees 72,000. Now what if we use this machine for 2 years? Okay. If we use this machine for 2 years, the total running cost for 2 years will be 76,540 and the depreciation cost will be 60,000. We are going to add these two. 60,000, very easy, but For the purpose of next step, I am using the calculator. 76,540. So it is 1,36,540. But this is after using the machine for 2 years. So it should be spreaded in 2 years. So we are going to divide it by 2 years. Because this is total cost of using the machine for 2 years. And average total cost for 1 year comes to 68,270. Now what if we use the machine for 3 years? First of all, the running cost for third year is 45,760, but we have to consider running cost for 3 years. So add it to the total of 2 years, it comes to 1,22,000 3 years. This is running cost if we use machine for 3 years. This is total of 3 years. Add the depreciation cost 1,22,300 plus 79,200. It comes to 2,01,500. This is the total cost if we use machine for 3 full years. So it should be spread in 3 years divided by 3. 67,167. I am ignoring the decimal values. See, this is gradually decreasing. Okay, now if we use the machine for 4 years, what will happen? The maintenance, rather running cost for third year is 53,400. Add these to the total of 3 years, it comes to 1,75,700. This is the total running cost of using the machine for 4 years. Add the depreciation value 1,75,700 plus 91,200. It comes to 2,66,900. This is for 4 years. This is the total cost if we use the machine for 4 years, full 4 years. So it should be spreaded to 4 years. So we are going to divide it by 4 years. It comes to 66,725. 66,725. See, gradually it is decreasing. Now we have only 1 year data because this is the question which was asked many a times in different years examinations. If we use the machine for 5th year, the total running cost for 5 years will be 2,39,300 and the depreciation cost for 5 years will be 1,700,000. So it comes to 3,40,000. And this is for 5 years. So it comes to 68,000. Yes, this is the key point. See, this is the key point. What happens exactly? Yes, first of all, it is the lowest at this stage. Okay, it is the lowest at this stage. But see, still in the 5th year, the running cost for the year is still less than the lowest possible average total cost. But the more important thing is the average cost has started to increase. Not only that, the average cost for 1 year is now greater than running and maintenance. So it is advisable to replace the machine at the end of the 4th year itself. Even though the running cost for the 5th year is less than the, say, 4th year average total cost. We should replace this machine at the end of the 4th year. So you can write as your, say, final answer quotation that this particular machine should be replaced at the end of the 4th year because for the 4th year the average total cost is the lowest. From the 5th year it starts to increase, and not only that, it is now greater than the running cost of the 5th year. So it will be now costlier to continue to use this machine. So for this particular case, our conclusion is this machine should be, or the company should replace this machine at the end of the 4th year. That's it. Thank you very much.